another
Yeah,
I
go
had
ahead.
another question. Yeah, it's great that you can merge the two paradigms. But some other work that we had done previously, we looked at having multiple state machines that were somewhat independent of each other. So if you imagine like tracking different dialogue topics and you make progress on some, and then you shift your topic back and forth. So
Right.
does your system allow that, or does it have to be one big state machine with maybe
Right. So
several areas?
I think we have a part of that, but not, I think the whole thing that you're getting at. So there is a mechanism to create independent state machines, and then you can link them up. But the loss of, I think the loss of power from the full thing you're talking about is that the system does not still maintain it doesn't maintain a state per topic. So when you take them independent state machines and then you can combine them, you can do that very flexibly, but it essentially creates one big state machine, just as a sort of just straight combination of the components you are working with.
So it
Um,
does that under the hood, but I mean, you would just create the two little ones and it would kind of multiply everything out.
Yeah, there's basically, I mean, we just have like an API set up where, where you can, you can set up a chatbot that's one state machine, and then there's an API, like just some method calls to actually link it to another independent one and kind of create this larger composite state machine. But I think what you were originally talking about, correct me if I'm wrong, part of that is actually tracking like if you're in like a movies topic and you make some amount of progress, and then maybe in the middle you switch to a sports topic and you make some progress there. When you go back to movies, there's some you sort of pick up where you left off. Is that what you're
Well,
talking about?
that's maybe one application, but yeah, I'm not sure for sports and movies. I mean, where you left off, really, you kind of just care about the history of what you've already learned about somebody.
Yes,
So
right.
when you move to another topic, you've lost the immediate transition. But I mean, you might want to keep track of things like, well, there's a good example. So questions under discussion was something we had in the Trinity framework, for
Yeah,
instance. So if you asked a question and then I kind of diverted it a little bit, then maybe we want to come back to the question that's still on the table, and we can
right.
do that in certain ways.
Yeah,
Another example is like we might want to separate grounding structure of what we've kind of understood about what we're saying from our progression within the topic. So or negotiation would be another kind of thing of what's on the table, what's the offer on the table. We can kind of
right.
have a lot of digression. It's like I want to sell you a car, and so here's this nice Porsche, and you're saying, but I don't have enough money for a Porsche. And then we go into your finances, and I say you can save
Yeah,
you a lot of money, so now you can, and then we can come back.
right.
So yeah, there are a bunch of things like that where um, you want to keep track of the very local, what can I say next, as separate from, how are my goals progressing, and other aspects of
Right.
or tracking multiple goals basically.
Yeah, I see what you're saying. So, I mean, I would say that yes, there actually is support for this. This I think is primarily captured with the idea of storing just a like tracking a set of variables that persist throughout the conversation. So, what you could, I think the sort of path to implementation of what you're talking about would essentially be to create a create essentially independent bots for each topic you want, and you can make the transitions on the topic dependent not only on just what the user input says, but also on the set of variables you want to maintain. So for example, in like the negotiation, like what items are on the table, or maybe certain item values that the other party has revealed to you. You can track these as variables, and this is where using update rules makes this flexible, and
Right.
it sort of is more in line with, I think, what you've
Yeah.
been doing and done in the past. And so you can sort of use that, you can use that set of variables to track where you are just as much as the actual like which node in the dialogue graph you're at,
Yeah.
and then given these independent state machines, linking them up is trivial. So yeah.
Mhm. Okay, thanks.
Yeah. Yeah. Do we have other questions from, I see actually a couple more people have joined. Yeah. Thanks for stopping in.
Hi.
Hi.
So yeah, so I think this seems like a really cool application. I was curious, what applications have you used this framework in already?
Right. So the primary use that we've been doing it for is we've been participating in the Amazon Alexa Prize competition. And so
Okay.
we've used it in that direction, which is a chat-oriented system. So that's been our main one. And that's involved sort of a lot of coordination between team members developing different things. And also sort of unfortunately, a lot of handcrafted intervention into our system. And so that's where we found the use. It's also been used, my advisor, Professor Gino Choi, also implemented it as an educational tool in his computational linguistics course. Essentially, he grouped up everyone all the students in the class into teams of like, I think 3 people per team. And then he had them each implement a chatbot as a way of teaching you know, some basic, you know, CL concepts like, you know, POS tagging or whatever, and then they would implement in the chatbot. And so yeah, it has been used at sort of a beginner-ish level there as well. So yeah, but I would say it's very young. I built the majority of the code in, I think, December and January. So yeah, these are the 2 main use cases that, yeah.
Okay, cool. Thank
Yep.
you.
Just a very basic question, James.
Sure.
Thank you. It's very interesting.
Thanks.
Are the libraries usable in Python, or in which language can you
right.
use them?
Yeah. So it's all in Python. Yeah. If there's a GitHub page, I think if you just Google it, it'll actually pop up. And yeah, it's a Python library, and you just pip install it.
Right. Well, thank you.
Yes.
Hello.
Hello.
Hello. Can you hear me? My name is Yuka Kobayashi. So I have some questions about your system. I can't understand. Your system is rule-based or statistical-based. I think the user can write rule-based some rules for this system, but the background is statistical. Is that right?
So it's not, the decisions it makes are rule-based. You can implement some statistical reasoning into it, but it would essentially be up to you to implement that within the update rules mechanism of the framework. So
how robust is your system for any variety of phrase?
Can you, how robust is it for what? Can you repeat?
How robust is the system for any variety of utterances? So,
for like variation in the user input.
Yes.
Okay, so I guess, so like the framework tackles NLU. Well, I would say maybe the first answer to that question is that it is a framework. So to some extent, it is like, I guess, the developer using the framework's job to capture whatever whatever variability in the user input is sort of on the developer's shoulders to make sure they capture and classify what they want. But the mechanisms we provide to do that within the framework take a sort of, I guess, 2-pronged approach. So the one is pattern matching, which is just completely rule-based. We make the natex, which is our sort of variant of regular expression that just has a little bit of a nicer syntax for natural language pattern matching. So that's sort of the rule-based formulation that's very like quick to develop, but obviously there's normally a very substantial loss of accuracy whenever you only use the the rule-based like pattern matching approach. And so that's why we also were sort of, another goal of the framework is to allow the freedom of the developer to integrate whatever NLP models they want very easily, and they can even do that in tandem with the pattern matching. So you could have a specific classification of the user input. I guess you might call it like an intent of the user. You can classify it partially on pattern matching, and then in the pattern matching actually embed like an NER model that runs and spits out some input or whatever you want. So the actual pre-built models we have are very basic. We basically just use like Spacies implementation, things like this. But essentially, when if you read the documentation or things like that, the like macro or function call mechanism in our natex formulation allows you to sort of put in whatever, basically however flexible a NLU system you can create into the framework.
Oh, okay. Thank you very much.
Yeah. Okay, I think Alex, did you just join the call? If you have a question, you can go ahead, or I can, field anything from existing people if anyone has anything.
One thing, I don't know if you're set up to do a live demo. That might be.
Oh yeah, sure. Here, I can share my screen if you want. Yeah, I have some examples built up. Let me see. Okay, can you guys see my pie chart?
Yeah.
Yeah. So unfortunately, all my demos are pretty. I mean, they're pretty basic, but I think it's probably better to illustrate just the simplicity with which the syntax actually translates into a system. I haven't built any example to show that's like larger and actually produces a good conversation because yeah, I can't really show our Alexa prize system, unfortunately, until the competition's over. Otherwise, I would do that. This
What about the student systems that you have on the GitHub?
Oh, right. Yeah. I don't know. I think it would take a second for me to actually download one of those. Yeah, I mean, some of them, of course, there's huge range in variability as to the quality of those. But yeah, a couple of them are pretty sophisticated. Yeah, I think, yeah, the students made some, yeah, some of them are interesting. One is like a chat about sort of in the like therapist chatbot direction about how people deal with stress, and I think that one was pretty good. But yeah, so essentially, as far as the demo goes, and I guess you saw it a little bit in the video. Yeah, so we have this sort of hierarchically nested.
Oh no, never mind.
Oh, go. Okay. Yeah, so basically, the sort of rapid prototyping way to add content into a bot developed in the framework is to use this nested JSON syntax. It sort of works as the like social media, like the replies are nested within the responses, and we just alternate here between like the system saying hello, and then this is an intent classifier that's looking at the similarity of the user response to this like how are you question. And then so basically after the system says hello, these two intents will be the two classification options for the user input, and you'll just kind of go there downwards. So So I think the main branch here in this in this toy example is at the beginning, it's classifying the user, asking how the bot's doing versus something about the weather. You know, if they want to know the weather. Yeah, it's pretty simple, but yeah. Whenever you run the system, it does take a second. I tried to make this faster, but it does always take a second to run because it's just loading the spacey embeddings. But yeah, there it goes.
Is this like a one-time cost only for the first?
Yeah, it's just a one-time cost.
So then you can get quick.
Yeah.
Yeah.
Yeah, there's actually there's another method to even if you wanted to go really fast, and you can process. I think it maxes out at somewhere around like 300 to 500 ish like pattern matching expressions. Of course, within a single turn, and that'll take about like a second to 2 seconds of processing, which is sort of like the most users seem to tolerate in our experience.
Yeah.
So yeah, that's kind of the performance that it maxes out at. But you can basically achieve that by pre-compiling a lot of the NATEX expressions beforehand, and that's how we kind of optimize things. But yeah, anyway, here. So if I just reply here saying something like is it cloudy outside? Our very simple intent classifier, which is basically just based on word embedding similarity, will recognize this intent and will sort of drop down into this level of where the code's at here. And then from here, the conversation basically just ends. We have an error transition, which will match anything. So I can, you know, whatever I type here, it's just going to say bye and exit. But yeah, we sort of settled on this syntax because it just was, you know, I was really going for adding content at the speed of thought or as close to it as possible for the handcrafted elements, because we don't want to, you know, spend any time on that, obviously. So, but yeah, I guess this is also a demonstration of how, well, of course, you can use the sort of regular expression like pattern matching. What we actually were doing here is basically completely relying on a model, albeit a very simple model, but you could basically, you know, if you wanted to train whatever classifier or database, you know, database query you wanted, you can easily insert it into the rest of this handcrafted material. So yeah, any other questions?
Can you explain a little bit how it's using the embeddings?
The embeddings? Oh, so it's very not interesting, unfortunately, because we were basically just trying to get something up quick for the, mostly like for the undergrads to use in the class. So the embeddings are actually just, it's just the average embedding similarity between the user input. So for this, like, is it cloudy outside? We just, you know, tokenize, look up these embeddings and take an average between that and each example in this in the arguments of this like intent call, and then the maximum average embedding similarity will be recognized as the score for this entire intent classification like trial, and then that score is simply compared to this one. So when I said, is it cloudy outside, it just simply was looking at the average embedding similarity between, is it cloudy outside versus this, like, how are you?
Right.
And
yeah,
compared
so
to this.
You have a predefined, I cannot, it's like very small in my
sorry,
screen.
here, let me.
So basically, you have a predefined answers, and all of them, of course, have their representation in an embedding, and then
Yes.
you compute the embedding that is produced by the phrase that
Yes.
the person input, and then you choose the one that it's the cosine, the maximum cosine similarity.
Yeah, that's exactly right. So kind of this example is very in line with a lot of like the commercially oriented frameworks like Google Dialogflow. Like this is basically what they're doing. That they have a much more sophisticated way of actually comparing the training examples to the user input. But essentially that wasn't our focus. I mean, you could use whatever intent classification model here. So this is just one easy approach that sort of the commercially oriented frameworks have settled on as a quick way to like use a model, but not make it very, I guess, not require a lot of expertise to integrate it. But of course, I think some even more interesting ways to use this would be to even have a, like for example, instead of using an intent classification model, you can use a, maybe a tagging model in the update rules and sort of like pick out information from what the user says globally and store that in the variable table. And that information will just persist throughout the conversation. It can sort of alter the conversation path as you go. And that, I think that's a more interesting use case, but that's getting into, you know, a little bit of a more complex use case.
More complex. Yeah. All right. Thanks for your answer.
Yeah, sure.
I'm gonna head off to other session, but thank you so much.
Yeah, thank you so much. Yeah, thanks for stopping in. Hi, Alex, I don't know if your volume is on, but if it is and you have a question, yeah, feel free to ask.